Okay, this presentation is called Study of Triangles, 5th series, Measuring Angles, the Sumerian story, and it's on page 190. So this is an introduction to the idea of measurement of angles. You'll need the fraction in sets and a ruler, and that's all that's really required. Okay, so I'm going to get one of the fraction in sets, which is, in this case, 1/3. And my angle is right here, right? And I want to measure the size of this angle, like how big it is, right? So is it small? Is it big? I want to have a way to measure this. Well, the only thing I know right now to measure something is, to use a ruler or a tape measure, but that just helps me measure the length of the sides, right? In this case, it's 5 centimeters. It doesn't really help me measure how wide the angle is, right? Because you can see that if I measure it up here, it's really little. If I measure it down here, it's bigger. So that can't be a good measure. So we needed to come up with a new form, a new way to measure, a new instrument, and a new way to measure the size of angles. So it turns out that to measure the size of an angle, you really need a circle. And I'm going to show you why. So, a long time ago, probably about over 2,000 years ago, there were these people called the Sumerians. The Sumerians were very, very smart people. They were scientists and mathematicians. They were really into discovering about nature and their world. There were also Sumerians that were very interested in study of the skies, astronomy. They were interested in taking a look at the stars and making investigations. Because you have to remember, back then, over 2,000 years ago, people didn't know very much about how the solar system worked or how the universe worked. Okay, so if you can picture, here's the surface of the earth, and I'm going to have my little Sumerian here. And he is looking up at the sky. And he goes out every night at the same time, looks up at the sky, and he looks for the brightest star, because he knows that he can recognize that star. So he looks for the brightest star, and it turns out one day, the brightest star is right above his head. So it's really exactly above his head. It's the brightest star. And then, so it's right there. So then he comes out exactly 24 hours later, the next night, and he notices that his star has moved to here, just a little bit over from above his head. Comes back the third night and sees that the star has moved over again in the sky. He does this night after night after night after night. Comes out at the same time every night, records where the star is, and it keeps moving. The star just keeps going round and round in the sky. Keeps moving. Until one day, I'm actually going to move the stars here for now, so I want to show you something. So let's just pretend that really our guy is down here. Okay? Put a little curly hair on him. Okay, so our stars are moving and moving and moving until one day the star literally disappears behind the horizon. He can no longer see it. Okay, he doesn't know, is it there, is it not there? He just doesn't know. He's just making observations. Okay, so turns out that he doesn't see the star for 6 months. And lo and behold, after 6 months, his very bright star appears again on the other side of the horizon. And again, he comes out night after night after night and watches the star. And it's moving from the horizon back towards being right above his head. It arrives back where it started about 360 days later. 360 days. So we know today, of course, that a star, because of the rotation of the Earth, a star will take 365 days to make a full circle around in our sky. So he was pretty close. This was, remember, 2,000 years ago. All right, he got very, very close. So we actually use this idea of a circle to measure the size of angles. And it turns out that the distance that one star moves in one day is equal to 1 degree. So it's 1 degree. And then we write it like that. Okay, 1 degree. And it takes, according to our little Sumerian guy, 360 degrees to make it all the way around the circle. All the way around the circle. And to this day, this is how we measure angles. We have a special measuring tool called a protractor. This is called a protractor. And we'll have a lot more to say about the protractor later on. I have my little Sumerian guy right here. Okay, and the stars are above his head. Day 1, the star will be at 0. So let me hold this up so you can see it a little better. Okay. Day 1, the star will be at 0. I'm sorry, day 0. After 10 days, the star will be at 10 degrees. After 20 days, the star will be at 20 degrees. After 90 days, it goes behind and disappears from the sky because it goes beneath the horizon. It takes another 6 months or another 180 degrees to get all the way around. And here it reappears on the other side of the sky and then works its way up, 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 up. And at 360 degrees or 360 days later, it is again on top. All right, so I'm just going to write for you the word protractor so you see how it's spelled. Protractor. It is the protractor. And like I said, we're going to be looking at the protractor more closely over the next few presentations. Okay, as a follow-up, I would like you to please draw this story in your geometry notebook, and I would like you to draw this example of the protractor as best you can.